So now I'm going to work questions 6 through 10 on the practice test. This is question 6. Solve for x. The equation is 3/4 x plus 3 equals -2. To solve this equation, we want to isolate the variable x on one side of the equation. To do that, we need to move the 3 and the 3/4 to the other side of the equation. And we do that with opposite operations. We're going to move 3 first by subtracting 3 on both sides. This gives 3/4 x equals -2 plus -3, which is -5. On the left-hand side, we have 3/4 x because 3 minus 3 is 0, and that's how we moved that 3 to the other side. Then to get rid of the 3/4 on the left-hand side, we're going to multiply by the reciprocal. We'll multiply by 4/3. And whatever we do on one side of the equation, we have to do the same thing on the other side to stay balanced. So we're multiplying by 4/3 on the right. We can treat that -5 as -5/1. On the left-hand side, when we multiply, we get 12/12x, which is the same thing as 1x, and 1x is the same thing as x. On the right-hand side, we're multiplying fractions, and when you multiply fractions, you multiply numerator times numerator and denominator times denominator. So this is -20/3. And we always try to write our fractions in lowest terms, meaning no common factors. For this example, we don't have any common factors, so we have simplified it as much as we can. So we have our solution to this equation being -20/3. One more comment I want to make is that I did decide to move the +3 before moving the 3/4. So we're making that choice because we want to go in the opposite order of operations. So with order of operations, we typically handle multiplication and then addition. Here we're going to go in the opposite order, handling that addition first and then the multiplication. On this question, I want to solve the equation 3 times 8x plus 16 equals 72. When we solve an equation, we want to make each side as simple as we can make it before we start moving terms from one side to the other or solving for x. So we want this left-hand side to be as simple as possible by removing parentheses. So we'll use the distributive property, distributing this 3 to both terms. 3 times 8x is 24x. 3 times 16 is 48. That equals 72. And now we'll isolate x. We're going to isolate x using opposite operations. We're first going to subtract 48. That's the opposite of adding. That leaves 24x plus 0. 48 minus 48 is 0. And on the right-hand side, 72 minus 48 is 24. We have 24x equals 24. We're going to continue isolating x using opposite operations. So we'll divide by 24. 24x is 24 times x. The opposite of multiplication is division, so we're dividing by 24. 24 divided by 24 is 1, so we have 1x equals 1, which is x equals 1. So our solution to this equation is x equals 1. On this question, we want to solve the equation y over 6 plus y over 3 equals 4 over 7. You can see that we have several fractions in this problem. And we have a strategy called clearing fractions. And this clearing fractions method allows us to get rid of the fractions in the first step of the problem so that we don't have to work with them as we solve. Your answer may still have a fraction in it, but you won't have to worry about multiplying fractions or getting a common denominator once we clear those fractions in the beginning. So this clearing fractions method requires us to take a look at the denominators that we have in the problem, and we want to find the least common multiple of those denominators, 3, 6, and 7. So we want the least common multiple, and the least common multiple will be a number that all three of these numbers divide into evenly, and it's going to be the lowest number that does that. So there are several strategies for figuring out the least common multiple. You could write multiples of each number. Multiples of 3 are 3, 6, 9, 12, 15, 18, and you can continue on. Multiples of 6 would be 6, 12, 18, 24, 30, 36, and you can continue on. And we have multiples of 7, which would be 7, 14, 21, 28, 35. Now, so far as I'm looking through this list, I don't see any multiples that all three have in common. So I need to go a little bit further. So 36 is 6 times 6. 6 times 7 is 42. 35, the next one would be 42. And 3 being such a small number means that it has lots of multiples. So we would have to get a long ways, but eventually we would get to 42 being a multiple of 3 as well. So 3 is a common multiple, 42 is a common multiple, and it is the least common multiple of these three numbers. Now there are also other strategies that you can use to find the least common multiple. Another strategy would be to write the prime factorization. 3 is a prime number, so the prime factorization of 3 is 3. The prime factorization of 6 is 2 times 3. And the prime factorization of 7 is 7, since 7 is a prime number. Once you've written out the prime factorizations, you can choose numbers that are in common. So you choose factors that are in common. You can see that we have a 3 in common. And so that 3 is going to be used in our least common multiple, but only once. Then you're going to choose all of the factors that weren't in common and use that in your least common multiple as well. So our least common multiple is 3 times 2 times 7, which is 42. Now once you've gotten that least common multiple, you're going to multiply each term by the least common multiple, and that will clear the fractions. I'm going to multiply 42 times y over 6, 42 times y over 3, and 42 times 4 over 7. And then we can divide. 6 divides into 42 7 times. 3 divides into 42, 14 times. And 7 divides into 42 6 times. So now that we've canceled those fractions out, we get the equation 7y plus 14y equals 24. Now we can solve the equation without having to deal with those fractions. On the left-hand side, I have some like terms, and I'll combine those together. 7y plus 14y is 21y equals 24, and I'll isolate y by dividing by 21. We get y is equal to 24 over 21. We want to write that fraction in lowest terms. We have a common factor of 3. 3 divides into 24 8 times, and 3 divides into 21 7 times. So our solution for this equation is y equals 8/7. Solve the equation below. 11 times x minus 12 minus 9 equals 26x minus 246. First, we want to make each side as simple as possible. So I'm going to remove parentheses using the distributive property. Then I'll combine like terms. So on the left-hand side, we have 11 times x, which is 11x. 11 times 12, which is 132. Carry down that minus 9 and the 26x minus 246. Then we'll combine like terms on the left-hand side to get 11x minus 141 equals 26x minus 246. Now we've made each side as simple as possible, and now we want to collect all of the variable terms onto one side. So I have a variable term of 11x and a variable term of 26x. I'm going to subtract 26x onto both sides of the equation to collect those x terms on the left-hand side. And that will give negative 15x minus 141 equals negative 246. Now that I've got the variable terms on one side, I want to isolate the variable. I'm going to add 141 on both sides to get negative 15x equals, negative 246 minus 141 is negative 105. I'll divide both sides by negative 15 to isolate that x, and that gives a positive 7. So the solution to this equation is 7. Now remember, when you're taking a test, it's always good to take your time and check your answer. So let's do that for this example. What's nice about this is we can check by substituting that solution in for x and checking to see that both sides of the equation are equal. We have 11 times 7 minus 12 minus 9 equals 26 times 7 minus 246. 11 times 7 minus 12. 7 minus 12 is negative 5. Minus 9. We have 26 times 7. That's 182 minus 246. 11 times negative 5 is negative 55. And 182 minus 242 is negative 60. And on the left-hand side, we've got negative 55 plus 9, and that's 64. Okay, so negative 64. So the two sides are not matching up. So either I've made a mistake in my checking, or I've made a mistake in my solving. So let's see. I'm going to double check. Okay, so right here is where my mistake was in my checking. 182 minus 246 is negative 64. So we do have the solution x equals 7 to this equation. For this example, I want to solve the equation w plus 1 over 3 minus 6 equals w minus 5 over 2. So to solve this equation, I want to start by clearing fractions, since we have these two fractions here. The least common multiple between 3 and 2 is 6. So I multiply by 6 onto each term. 3 divides into 6 2 times. 2 divides into 6 3 times. And this gives 2 times w plus 1 minus 6 times 6, which is 36, equals 3 times w minus 5. So I've cleared the fractions in the problem. Now I'm going to make each side as simple as possible. I'll use the distributive property to get 2w plus 2 minus 36 equals 3w minus 15. On the left-hand side, I can combine like terms. 2 minus 36 is negative 34. And we'll carry down the 3w minus 15. I've got variables on both sides of the equation, so I'm going to collect the variables on the left. I'll subtract 3w to do that. This gives negative w minus 34 equals negative 15. Now that I've got the w on one side, I'll isolate that w. So to isolate, I add 34 to both sides. This gives negative w equals 19. Let me double check that math. Okay, so that gives a positive 19, and we'll divide by negative 1 so that we get our solution of w equals negative 19. So that's our solution to the equation w equals negative 19.
Thank you for checking out my videos. Have a great day.